Can you hear me, students? Right, okay. Right, okay. So we have to discuss few questions in the last paper, in the third paper book. Let's finish this paper book and let's go for the FWC paper after finishing this one, okay? So we were discussing about question number 3, part B. I think we completed that one. So today we have to start from question number 3, part C, from number 1. They have given some compounds, few compounds: sodium chloride, argon, CH3I, ethanol, C2H5OH. Which of the above species consist with the following interactions, right? So they have given a few interactions. Number 1 is hydrogen bonding. Hydrogen bonding. So when you consider hydrogen bonding, in which molecules that we can see hydrogen bonding? Tell me in which molecule types showing hydrogen bonding here, right? According to the given molecules, we know that yes, we should have OH group, NH group, O, HF group should be there in order to show the hydrogen bonds, right? HF group, if not HO group, if not HN group. So this is actually, these are the groups, at least these three groups should be there in order to show the hydrogen bonding. So therefore we can easily identify that the only molecule type that we can see which can show the hydrogen bonding is ethanol, C2H5OH, right? And the next one, number 2. Number 2 is actually dipole-dipole interactions. Dipole-dipole interactions are existing in the polar molecules. So tell me, what are the polar molecules in this list where we can see polar molecules? Definitely, the answer should be CH3I. Of course, CH3I. But again, I can tell you that ethanol also, C2H5OH also can be taken, because we know that hydrogen bonding is actually a type of dipole-dipole interaction. So therefore, we can take C2H5OH again in the list, right? We can take that one again in the list, right? Then the next one. Next one, they have given dispersion forces. Remember, students, dispersion forces means London forces, instantaneous induced dipole interactions. So we can see there definitely dispersion forces are existing between any kind of covalent compounds, regardless the covalent, polar covalent or non-polar covalent. So therefore we can say that we can take here argon, of course, because argon is actually a gas, noble gas. Then CH3I also can be taken, and C2H5 also can be taken, because they are covalent compounds. So between the covalent compounds specifically, there are dispersion forces, whether it is polar or non-polar, doesn't matter, right? So therefore dispersion forces are existing in argon, CH3IN, C2H5. And the next one, number 4. Number 4 is electrostatic attractions. We know that electrostatic attractions are present in where? Sodium chloride, because that is ionic compound. Since it is ionic compound, we can easily tell that electrostatic attractions exist in sodium chloride, NaCl. Right? So these are the answers for the question. Question number 3, part C. These are the answers. Question number C, part C, Rome number 1. Rome number 2 is urea is produced by ammonia and carbon dioxide according to the following reaction equation. 2 ammonia gas molecules are reacting with 1 carbon dioxide gas molecule to produce what? Urea. Yeah, any doubts? So are hydrogen bonds only in HF, NH and OH? Yes, we consider that hydrogen bonds are existing in HF, OH and NH, right? But there are a few exceptional molecules also which can show the existence of hydrogen bonds. Sometimes we consider that chlorine atom, right? Chlorine atom also very close to the electronegativity of nitrogen atom. So there are a few molecules actually that can show the hydrogen bonds in the existence of chlorine also. But we are not going to discuss about those things in our syllabus. They have given only about these molecules, HF bonds, OH bonds, and the NH bonds, right? Specifically, we don't discuss about those things. So I'm knew how to distinguish between polar molecules and non-polar molecules. Oh my God. Polar molecules and non-polar molecules, those are very simple theories. I think you have learned those things in your theory class, right? But anyway, right, it's okay, easy. Look at this one, Lilu. Now, in order to check whether the molecule is polar or non-polar, we have a factor known as dipole moment. So if the dipole moment is 0, we consider that molecule is non-polar. If the dipole moment is not equal to 0, we consider that molecule is what? Polar. For example, if I consider carbon dioxide. So in the carbon dioxide molecule, we know that oxygen is pulling electron toward it, and therefore there is a dipole moment towards the oxygen atom, right? So here mu, and here also mu, because in the other side also oxygen is pulling electrons. So therefore this is considered as dipole moment, right? So we know that these are behaving as two vectors. One vector is actually for the right hand side, the other one is for the left hand side. They are same quantities, same values. So therefore the resultant dipole moment becomes 0. If the resultant dipole moment 0, we consider that molecule is non-polar. Okay. Now just imagine we have a molecule like this, COS, right? If not, I'll take directly molecule like this, H2O. Let's take H2O. That's easy. Now among oxygen and hydrogen, we know that oxygen is pulling electrons. So therefore the dipole moment is towards the oxygen atom. So here mu, and here also mu. Dipole moment is there. And we know that if you take the resultant dipole moment, the resultant dipole moment is actually towards the upward direction, right? Just imagine these two are two vectors. So when you take the resultant of this vector, so the resultant force is actually towards the upward. That means mu r is not equal to 0. Then we consider that molecule is polar. So this is how we decide whether the molecule is polar or non-polar, right? Go and check your theories you have learned in your theory class. Okay. Right. Next one, calculation. Urea is produced by ammonia and carbon dioxide according to the following reaction equation, right? And 2 ammonia gas and carbon dioxide producing urea and water. Calculate the mass of urea obtained if 637.2 grams of ammonia and 11,142 grams of carbon dioxide allowed to react. Right, okay. It's okay. Calculation. Let's go for the calculation. So when you go for this calculation, you can see that since they have given the reaction, we can easily do the calculation. 2 ammonia gas reacting with carbon dioxide to produce CONH2 twice gas and H2O liquid. Remember students, urea is a molecule like this, C double bond O NH2, and this side also we have NH2, right? So this is considered as what? Urea. Okay. Then you can see that check whether the reaction is balancing. 2 nitrogen atoms, 6 hydrogens, 2 oxygens, carbon is 1. Okay, right, balancing. Then they have given the mass of ammonia. So since they have given the mass of ammonia, first of all, let's take the molar mass of ammonia. Nitrogen 14, hydrogen 1 into 3 grams per mole. So when you take the summation, answer is 17 grams per mole. Then what is the number of moles of ammonia? They have given the mass of ammonia 637.2 grams. This is divided by 17 grams per mole. Check whether this is divisible by 17. Right? How many 70s are there? 17s are there for the 63. 4? No, 3, right? So therefore, 1, 5, here 2, 12. 127. For 127, how much? For 127, we can take at least 6. 7. Then we have 119, and here we have 8, right? 82. For 82, how much? For 82, we have 17, 5. No. Then 4. 82 here, 68. No. So likewise, we are not getting an exact value for this one. So we will have a value like this, 140. For 140, how much 17 we have? One 19, 17, 48. Okay. So therefore 136. And this is 40 again, and this is okay. So for 1 decimal point, let me take this one as 37.5 moles. Okay. Am I correct, students? If my calculations are wrong, tell me. This is the ammonia number of moles that we can calculate. Okay. Right. Then, so the next one, let's see. They have given the carbon dioxide mass also. Carbon dioxide, we know that molar mass is very easy, 44 grams per mole. Carbon is 12, oxygen 16 into 2 grams per mole. Then we can tell that, look at this one, we can calculate the number of carbon dioxide moles as 1142 grams divided by 44 grams per mole. Exactly, this is not divisible by 44, but anyway, let's do this one from the long division. If you want, you can take the logarithms also, doesn't matter, right? Okay, so 44 into 3, how about it? No, right? Therefore, let's take 2, 88. So therefore 6 here, and 10 means 20, 262. 262. How about 5? 0, 2, 220. Yeah. Yes, 5. Then we have 242. So 420. 420 means definitely that should be 9. That means we have the answer as 25. Okay. My 9. 36, 3 there. Yeah, 396. Take the difference. 4. 2. Yes, 24. So for 240 again, what is the answer? We can take 5, then 220. So for 200, how much? 4. So approximately we can tell this one as 25.95. Yeah? Let me take this one as 25.95 moles. So these are the moles of carbon dioxide. So these are the moles of carbon dioxide that we have added, right? Then we need to remember, we need to find out the urea mass. So we know that initially we have added the initial moles of ammonia and carbon dioxide. The initial moles of ammonia is 37.5, and carbon dioxide moles that we have added is 25.95. These are the initial moles. So here we have to find out the limiting reagent. Then only we can do the correct calculation here. How we can find out the limiting reagent? I told you that in the theories we discussed that limiting reagent means the one who, yes, the one who totally consuming in the reaction without remaining, all the reactants are consuming. So among ammonia and carbon dioxide, who is the limiting reagent? Let's take that ammonia is the limiting reagent. If ammonia is the limiting reagent, we know that stoichiometry ratio between ammonia and carbon dioxide is 2:1. That means if there are 2 moles of ammonia, there should be at least 1 mole of carbon dioxide to react with it. Now we have 37.5 of ammonia. Then how much of carbon dioxide we need to react with these 37.5 moles of ammonia? Half of that one. Do we have half of that one? Yes, we have half of that. Carbon dioxide, we have extra amount. So therefore, carbon dioxide is not the limiting reagent here. So the limiting reagent here is what? Ammonia. Just think about carbon dioxide. If you consider carbon dioxide is the limiting reagent, we have 25.95. So in order to react with 25.95 of carbon dioxide, we should need, we need twice the moles of carbon dioxide from ammonia. So what is the twice of this one? So twice of this one is actually greater than 50. So, but here we have 37.5. Then this is not the limiting reagent. Limiting reagent means the one who totally consuming in the reaction according to the correct stoichiometry ratio. So here we can consider ammonia is totally consuming because it's the limiting reagent, right? So we have discussed these things in the theories perfectly. We have done calculations also. Then now we can calculate here change. Change means the reacted or the formed amount. Then we know that ammonia 37.5 moles reacted. Then tell me students, from carbon dioxide, how much is reacting? What is this negative sign? Negative sign is representing that reactant is consumed. The amount of ammonia reacted, that is 37.5. So the carbon dioxide amount will be half of that one. So half of that one will be here 25. And 7 means, if you divide this one by 37.5 divided by 2, the answer. 1, 2, 17 means 8, 16, 15 means 7, yeah, 18.75. 18.75 of carbon dioxide will react with this ammonia. Then tell me how much of urea should produce from that one. According to the reaction stoichiometry, 2:1:1. 1, 1. So therefore, the urea amount should form from the reaction is 18.75 plus. Plus means the one who forming. Minus means the one who consuming, reacting. Then the urea amount is 18.75. So this is enough for our calculation. So these data are enough for, this data is enough for our calculation. Now we can find out, we know that urea number of moles produced from the reaction, right? Listen to this one carefully. Do the calculation. We know that the amount of urea produced from the reaction is equal to 18.75 moles. Students, they are expecting from us to calculate here the mass of urea. Therefore, let's calculate the molar mass of urea. What is the molar mass of urea? One carbon is there, 12. One oxygen, 16. There are two nitrogens, 28. How many hydrogens are there? 4. When you take the summation, 10, 20, 2 here. So the answer is 60. 60 grams per mole. 60 grams per mole is the molar mass of urea. Then you can easily calculate here the mass of urea. Mass of urea is equal to 18.75 moles multiplied by 60 grams per mole. Per moles will cancel off. And we know that we can shift the decimal point here by giving this 0 there. 187.5 multiplied by 6. What is the answer? 30, 3 here. 42, 45, 4 here. Here 48, 48, 4, 52, 5 here. 6, 11. So therefore answer is 1125 grams, which means 1.125 kilograms. 1.125 of kilograms will produce when you add 37.5 grams of 637.2 grams of ammonia and 1142 grams of carbon dioxide. Okay, so this is the calculation. First of all, you need to calculate the number of moles and then find out who is the limiting reagent. According to that one, we have to find out the urea number of moles produced from the reaction, take the molar mass, multiply the moles, get the mass of the urea. Okay, 1125 grams of urea, 1.125 kilograms. Okay, do the calculations. So is it fine to take for one decimal place? Yeah, it's okay. Doesn't matter. The reason I took here for the second decimal point is 7.5 is a nice value. Here 9.5 is actually some kind of a nice value, right? Because if I take the approximation here, this will be 26. This is also divisible by 5. This is also divisible by 5. But 26 is not exactly giving a whole number by dividing 5. So that's why I took here 25.9. Right? So, but it's okay. You can take here 26. And if you want, you can take here 38. According to that, your answer also will be changed within very small values. But it's okay. But my recommendation is actually when you're doing the calculation in the examination, at least try to take 2 decimal values. That is good for you. Right. Practice these calculations. Huh? Shall we move to the next one? Quickly. Right. Let's move for the part D. The wavelength of red color is 749 Newton meters. Calculate the frequency and the energy of photon of this radiation. You very easy. Very, very easy. So we know that how to handle the equation E equal h nu as well as E equal hc over lambda, right? In the first unit, we'll discuss about the energy of electromagnetic radiations. So this calculation is related to that theory. So they have given the wavelength. Therefore, we can, since they ask in the frequency, we can use C equal nu lambda, right? Then frequency is equal to C over lambda. So C is velocity of light, 3 into 10 to the power 8 meters per second divided by, and what is the wavelength? 749 nanometers. 749 nanometers, we can write down that one as 10 to the power minus 9 meters. Nano means 10 to the power minus 9. And then in the correct scientific notation, we can put this one 7.49 10 to the power minus 7 meters. 7.49 10 to the power minus 9 meters. Meters will cancel off. So therefore, the unit is per second or hertz. So minus 7. Minus 7 will go for the numerator as 10 to the power 15. And here we have 7.49 per second. Students, I told you that when we are doing the logarithmic calculation for these kind of things, I see that the numerator is lesser than the denominator. So in this kind of a case, we have to face for the negative logarithms. In order to avoid the negative logarithms, I'm going to put here 30. 30 multiplied by 10 to the power 14, because I can give 110 to this 3, then it becomes 30, and then 10 to the power 14 divided by 7.59. So now we can do the logarithm calculation easily. We won't get the negative values, we will have positive values. So log value for 30 is 1.4771. What is the log value for 749? 749 is 8745. 45. Okay, now take the difference. When you take the difference, answer will be here 6206. So 0.6026 antilog 4005 10 to the power 14 per second. So approximately we can tell what is the answer. 4 into 10 to the power 14 hertz or else per second. Okay, so this is the final answer, frequency. Then they are calculating they're asking us to calculate the energy of a photon. Very easy. We know that energy of a photon can be calculated using E equal h nu, right? Who introduced that equation? Max Planck. He said that the energy is actually quantized, so that quantized particle energy can be calculated using E equal h nu. So since we know the frequency, directly we can substitute 6.626 10 to the power minus 13 4 joule seconds multiplied by 4 into 10 to the power 14 per second, right? Then E equal. So just multiply 6.626 by 4, 24, 2 there, and 0, 1, 25, 2, 26, 10 to the power minus 20 joules. So we can tell that 2.65 10 to the power minus 19 joules. This is the energy of a photon. If they ask you to calculate the energy of a photon more, what you have to do? You have to multiply this one by Avogadro constant, 6.022 10 to the power 23, and you will get the answer for the energy of a photon, right? So they haven't asked anything about like that. They have just asked about the energy of a photon, right? So these are very easy, simple calculations we did in the first unit. Sorry. 653 10 to the power minus 17 is wrong. Minus 19 is the correct piece. Yeah, Mariam, you can have the recording of this class. Every session I'm going to do, every session I'm discussing will be recorded. Don't worry. Recordings are available. Sometimes, actually, if there is a technical issue, if I forget to record, then only the issues are there. When you log to the session, check whether I'm recording the session. Now recording is going. Sometimes I also forget. Right? Okay. Easier. Let's move for the question number 4. Label of a commercial HCl as acid bottle consists with following data. We have done this calculation in theories again. Very easy. A density is given, weight percentage is given, molar mass is given. What is the volume of the acid be taken to prepare 400 cubic centimeter of 0.2 moles per cubic HCl solution? First of all, we need to calculate the concentration of this solution. Using this solution, we have to prepare 500 cubic centimeter of 0.2 moles per cubic decimeter HCl solution, right? Okay. Now, first of all, let's calculate the concentration of the solution in the chemical bottle they have bought from the shop. Look at this one. So this is the chemical solution which is commercially available. In the chemical bottle, they have labeled that the density of the solution is 1.12 grams per cubic centimeter. Weight percentage is given as 25. Molar mass is 36.5 grams per mole. HCl aqueous solution. Right, students, first of all, let's calculate the concentration of this solution. Right, I told you how to calculate this one, very easy. First of all, when we are doing the calculation, in order to find out the concentration of this kind of a solution, we have to assume that we have taken 1 cubic decimeter of volume from this solution, right? So by assuming 1 cubic decimeter of the solution has been taken. Now do the calculation. Now you have 1 cubic decimeter of the solution. So what we can do is, what we are going to do, we are going to find out the HCl concentration in the solution, right? Concentration means we know that number of moles divided by the volume. So density 1.12 grams per cubic centimeter multiplied by, you have taken 1 cubic decimeter of the solution. 1 cubic decimeter of the solution means 1000 cubic centimeters. You know the unit conversion. So this gives us the mass of the solution, but we need only the mass of HCl because we are finding the molar concentration of HCl. In order to find out the HCl moles, we need to have mass of HCl, mass of exact HCl. Then this is the mass of solution. When you multiply the density from its solution, its volume, you will get here the mass of the solution. So in order to get the mass of HCl, you have to multiply this one by 25%. Then this is the mass of HCl. In order to find out the number of moles of HCl, you have to divide this one by 36.5 grams per mole. Students, you have to remember these connections. We know that mass is equal to density multiplied by volume. Then you know that number of moles is equal to mass divided by molar mass. Okay? So that's what I have done here. Mass divided by molar mass. Then you will obtain number of moles. So these connections actually you have to know. These are the tricks we have to follow when you're doing the calculations, right? If you are familiar with these equations, you have to imagine them when you're doing a calculation, right? Then now you will get the number of moles of HCl, right? Then what we need to find out? Concentration. In order to find out the concentration, we need to divide the number of moles by the total volume. What is the total volume I have taken? 1 cubic decimeter. And then here 1 cubic decimeter. Now look at this one nicely. The sum of the units will cancel off and the remaining unit will be moles per cubic decimeter. Look at this one. Per cubic centimeter will cancel. Grams will cancel off. 4 moles will go for the numerator as moles and cubic decimeter will go for the numerator as per cubic decimeter, then moles per cubic decimeter. What else? The numerical values that are cancelling off, 2 zeros will cancel, right? And 36.5, 1.12, not divisible, but we can divide this one by 5. 25, 5. When you divide this one by 5, 7 for 15, 3. Okay, 7.3, right? 1.12, 7.3. Any connection? No, right? Then the answer is, you will have the answer here. 1.12 multiplied by 5. Answer is 6. 5.6 multiplied by 10, 56. 56 divided by 7.3 moles per cubic decimeter. If it is 7, we could have taken directly, that is 8. But unfortunately, that is 7.3. So therefore, we have to do the calculations, right? So divide 560 divided by 73. 560 divided by 73. How much? We have 7, 21, 2, 49, 51. Yes, 511. And here we have 9, 49. Then 409. That means 6. Then 18, 1, 43. Then 2, 5. 520. 520 means how much? 4, 12. No. 6, 18, 1, 42, 43. 43 and yeah, 7, no? 7. Then we know that it is repeating again. So therefore, answer is 7.67 moles per cubic decimeter is the answer. This is the concentration of HCl. 7.67, right? Did you get that answer, everyone? Okay, right, good. Some of you got the answer, right? Ashik, correct. Yes, that is the answer. Don't use logarithm calculations, the calculators. Do logarithms. If not, directly go for the long division and find out the answers. Ask in the question. So what's the volume is asked in the solution. Yeah, they have asked the volume, but before we take the volume, we need to find out the concentration, right? So without find out the concentration, actually we cannot directly go for the volume because they haven't given what directly. They have given the density of the solution. So we need to prepare a solution of HCl with this concentration first of all, right? And then from this concentration we are taking a volume. So that volume is actually equal to the solution that we are going to prepare. Okay. So this is the concentration of the solution which is available in the shop, commercially available solution. Now they are asking students, what is the volume of this acid solution we need to take to prepare 500 cubic centimeter, 0.2 moles per cubic decimeter HCl. We did these kind of calculations. Can you remember? Now this is the solution we have. Its concentration we found that one as 7.67 moles per cubic decimeter. And we need to prepare a solution using this one, which has 0.2 moles per cubic decimeter, 500 cubic centimeter, right? In order to prepare this solution, we have to take some volume from this. So what is the volume that we have to take from that one? I told you for this kind of a situation, we can apply here what? C1V1 equals C2V2. Because the number of moles that we are taking from this solution is exactly equal to this number of solutions in this solution. So therefore, we can apply here C1V1 equals C2V2, right? Okay, Nathan. Then we can find out the volume of that solution. 7.67 moles per cubic decimeter multiplied by V1. Here 0.2 moles per cubic decimeter multiplied by 400 cubic centimeter. Moles per cubic decimeter will cancel off. Then V1 is equal to 100 divided by 7.67 cubic centimeter. Right? Okay. So what is the answer for this one? So the answer for this one is, we can take that 100 is log value 2.000. 7.67 log value 67 76 7 8848. Take the difference. 2 here, 5 1 1 1 point. 1.1152. Take the antilope. 1152 13 0. We need 3 13 1304 cubic centimeter. We need to take 13.04 cubic centimeter of this commercially available solution in order to prepare 0.2 moles per cubic decimeter per 100 cubic centimeter HCl solution. Can you understand? Right. Any doubts? Sir, I didn't find the concentration at all, but still got the same answer. Is it possible? If it is possible, I think you have followed the short method. That's a good thing. If you got the answer without find out the concentration, that means you have followed a short method. And yeah, that's very good. How did you do that calculation, Rafa? Without finding the concentration? We can apply this concentration, no? I found the total mass of the solution and substituted density equation. Total mass of the solution. Is this the way, Rafa? How did you find out the total mass of the solution? Total mass of which solution? This one, no, this one. By the mass percent. Yeah. That means 1.12 grams per cubic centimeter multiplied by 1000. I didn't get it properly. Okay. So you do the calculation and send me. Let's see how did you do the calculation. Okay, Rafa. Let's see. Right. Okay. So anyhow, this is the way that we learn to find out the volume of the solution that we need to take from the commercial available solution in order to prepare the solution in this. Right. First of all, calculate the concentration, and then you can find out the volume by applying C1, V1, C2. Right. Quickly do the calculation. Right. Okay. Are we done? Okay. You send through the WhatsApp. Let's see. Okay, right. I got it. I got it. That means you have found the mass of the solution by considering the mass of HCl and then divided by the density. No? Yeah, that's correct. Very good. So that is also a good short method. No? Can you put that image to WhatsApp group? Then others also can see that one. Rafa, can you share that one? Right. Okay. Good. Right. Shall we move for the next part? Simple B part quickly. We have to finish this one. Right. Question number 4, part B. Read the question carefully. 0.21 gram of bivalent metal, capital M, is subjected to react completely with 100 cubic centimeter of 0.25 moles per cubic decimeter sulfuric acid. which is in excess. 32.5 cubic centimeter of 1 moles per cubic decimeter sodium hydroxide is used for neutralization of this excess acid. Find the relative atomic mass of capital M. During the reaction, only metal sulfate and hydrogen are formed as the products. Right. Okay. So they have given here a bivalent metal, 0.21 grams of a bivalent metal is reacting with sulfuric. But remember, students, they have added excess amount of sulfuric. Since they have added excess amount of sulfuric, after the reaction with metal, that sulfuric is remaining in the solution. So that remaining sulfuric is neutralized by adding sodium hydroxide. Actually, there are two reactions inside this question that they have given, right? Let's see. In question number 4, part B, bivalent means its valence is 2. Since it is metal, we can tell that the metal capital M is forming M2 plus. Then this is considered as what? Bivalent. Some says divalent, bivalent, both are correct. Okay. Now, this metal capital M is reacting with sulfuric H2SO4. They have clearly mentioned that the metal is forming M2SO4 sulfate, metal sulfate, and hydrogen gas liberated from the reaction. Right? And the remaining sulfuric in the solution is neutralized by sodium hydroxide. Right? So this is remaining sulfuric reacted with sodium hydroxide. So we know that sodium sulfate is produced plus water. In order to balance the reaction, we can put here 2. And here also 2. They have given the volume and the concentration of sodium hydroxide. Then we can find out sodium hydroxide reacted with remaining sulfuric. 1 moles per cubic decimeter multiplied by 32.5 10 to the power minus 3 cubic decimeters. Per cubic decimeter will cancel off. Then the answer is 3.25 10 to the power minus 2 moles. Then students, we know that number of sulfuric moles according to the reaction stoichiometry, 2:1 is the ratio. Then the sulfuric moles will be half of this one, 1.12 means 6, 1.625, 10 to the power minus 2 moles. So these are the remaining sulfuric moles. Okay, so these are the remaining sulfuric moles. And can you remember they have given that initially, right? The initial amount of sulfuric that they have added. Let me find out. This is the remaining sulfuric moles. After the reaction with metal, this is the remaining sulfuric. So the total sulfuric they have added, the total sulfuric that they have added to the solution is 0.25 moles per cubic decimeter multiplied by 100 cubic centimeter. We know that, students, 100 cubic centimeter means 0.1 cubic decimeter. Then the answer is, we can see that 2.5 10 to the power minus 2 moles. This is the total amount of sulfuric that we have added to the solution. I told you that when sulfuric is added with, to the solution in order to react with the metal, we have added excess amount. That means we have additional amount of sulfuric. Only few is reacting with M. There will be remaining sulfuric. That remaining sulfuric was neutralized by sodium hydroxide. We found the sodium hydroxide moles. Then we found the sulfuric that was reacted with sodium hydroxide. That means remaining sulfuric. Then the total amount of this one. Then tell me how we can find out the sulfuric moles reacted with this metal capital M. The difference of this one. Difference of these two will give the sulfuric moles reacted with capital M. Easy, right? Then we can find out number of sulfuric moles reacted with capital M. Reacted, let me write down reacted. Take the difference, 2.5 minus 1.625, 10 to the power minus 2 moles. When you take the difference, 2.5, 1.625, here 5, 7, and 4 means 8, 0. Okay. 8.75 10 to the power minus 3. These are the number of sulfuric moles reacted with capital M. 8.75 10 to the power minus 3 moles. Right? Remember, students, in order to balance this reaction, we know that here M metal is reacting with sulfuric H2SO4 and then it is forming M2SO4. Remember, M2SO4 is formed by like this M2 plus and SO4 2 minus. Then this one should be MSO4. Ne? Bivalent, so therefore MSO4. And here hydrogen. This reaction is balancing perfectly. We don't have to put here any other stoichiometric coefficients except one. So therefore this reaction is balancing. Then we can tell that the reaction stoichiometry between M and sulfuric is 1:1. That means the M metal is, number of moles of M metal is 8.75 10 to the power minus 3 moles. Okay, try to understand. Okay, try to understand. According to the reaction, sulfuric and metal M, reaction stoichiometry is 1:1. We found out the sulfuric moles reacted with capital M, which is 8.75 10 to the power minus 3. Then M moles also same as that, 8.75 10 to the power minus 3. Got it? Do you have any doubts, anything? So now tell me how we can find out the molar mass of capital M. Tell me. Tell me what is the molar mass of capital M, how we can find it. Anyone got the answer? Put your answers in the chat box quickly. Don't wait until I do. Yes, Asma. That is the equation we have to use. Yes. Put your answers in the chat box. Rafa says, okay, let's see. Sehanti, yes. Two of you sent me the answers. Both are same. What about the others? We know that, students, in order to find out the molar mass, we need two parameters. Mass divided by number of moles, right? They have given that initially we use 0.21 grams. The number of moles is 8.75 grams per mole. Sorry, 8.75 10 to the power minus 3 moles. Then okay, capital M equal 10 to the power minus 3 will go for the numerator as 210. This is 8.75 grams per mole. What is the answer? 8.210 divided by 8.75. Answer is, we can take that 21,000 divided by 875. For 2,100, how many 875s are there? 2. Therefore, 150. So multiplied by 2 means 0, 1, 15, 1. This one, 1750. 0, 5, 3. For 3,500, how much? Let me take. Yes, it is 4. Ne? Your answers are correct. 2 here, 28 means 30. 3 here, 32, 35. Yes, answer is 4. Answer is 24 grams per mole. That is the correct answer. 24 grams per mole. So what is this metal? Now you can tell me the metal. Who is the metal? Who is having the 24 grams per mole? Yes, magnesium. The metal is magnesium. They haven't asked the metal, but okay, we know that that is magnesium. Right. So that is the end of that calculation. Quickly complete this one. Right. Okay. Are we done? Okay. Right. Now let's move for the part C. Part C, room number 1. So that is a theoretical explanation. Let's see. They're asking lithium iodide is more covalent than cesium iodide. Explain this. So what is the concept that we have used to explain this one? What is the theoretical concept we learn to explain this? Yes. Polarization. Polarizability of an anion and the polarizing power of the cation. Right. Let's quickly finish this one. Okay. Lithium iodide is more covalent than cesium iodide. Lithium iodide and cesium iodide. Right. So let me write down bullet wise. This is the thing. When you analyze these two compounds, you can see that, students, the anion is same. First of all, I'm going to write down that one. Anion is same because iodide. And then the second bullet point is the cation. So when we consider the cation, we can discuss about the polarizing power. We have discussed that when the polarizing power increases, the covalent properties are increasing, right? What will happen to the covalent properties? Covalent properties of the cation is increasing when the polarizing power increases. And the polarizing power, this is depending on two factors. What is the first one? Charge. And the second factor is radius. Charge and the radius. I told you that when the charge increases, polarizing power is increasing. When the radius decreases, polarizing power is increasing. That means charge is directly proportional to the polarizing power, while radius is inversely proportional to the polarizing power. Then we know that lithium plus cesium plus, they are in the same group. Therefore, their charges are equal, right? So we can tell that cation, charge of the cation is also same. Then the radius, we can tell that the radius of covalent radius of lithium plus cation is lesser than radius of cesium plus cation. We know that in the first group, lithium, sodium, potassium, rubidium, cesium. So down to the group, the radius is, atomic radius is increasing. Okay? You know that part. So therefore, cesium plus cation has the highest covalent radius. Then, according to this theory point, according to the polarizing power theory point, as I mentioned you, when the radius increases, what will happen to polarizing power? Polarizing power is decreasing. Then we can tell that the polarizing power of lithium plus cation, polarizing power of lithium plus cation is greater than cesium plus cation. Then we can tell that covalent properties of lithium plus, that means lithium iodide compound is greater than cesium iodide compound. That means ionic properties of cesium iodide is greater than lithium iodide, right? So you can explain these things using simple bullet points. No need to write down the essays. Huh? In the second one, students, there is a small mistake. They have given a structure. No? In that structure, correct that there should be two hydrogens connected to this carbon atom in this way. Correct the structure that they have given. And this is the first carbon atom. This is the second carbon atom. This is the third carbon atom. This is the fourth carbon atom. And they have given 2 for this oxygen. And I think that is not needed. It is not needed. Sorry. Then they have given, consider the following molecule. This is the molecule from number 2. State the hybridization of first, second, third carbon atoms of the above molecules. Very easy. When you consider the hybridization, I told you that we have to consider the VSEPR electron pairs. That means non-pi bonding electron pairs. If the non-pi bonding electron pairs are 2, we consider that hybridization is sp. If it is 3, sp2, 4, sp3. If it is 5, sp3d. If it is 6, sp3d2. Likewise. So here we can see that 1, 2, 3. 3 Vesp pairs are there. Then we can consider that what is the hybridization? sp2. And here 1, 2, 3, sp2. Look at this one. Here we have carbon hydrogen bond, right? And if you spread the bonds here, there are 2 carbon hydrogen bonds. That means there are 4 bonds. Hybridization is sp3. 4 Vespa pairs are there. What about the fourth carbon atom? 1, 2. There are 2 Vespa pairs. Hybridization is sp. Right? Very easy. Sketch the shape of the above molecule indicating the bond angles. Right, okay. So you have to draw the sketch of this one by indicating the bond angles. I'll draw this one in this way. We know that around this carbon atom, bond angle is 120 because trigonal planar shape. And here also some kind of what? Trigonal planar shape. That means here we can say that bond angle around this carbon atom is 120. And here also same as that. And here, what you can say about this one? Here I'll give you that. One bond is outside the whiteboard and the other one is behind the whiteboard, right? These 2 bonds. And carbon oxygen, this is in the same plane. And here we can tell that oxygen has 2 lone pairs. Carbon, triple bond, carbon, hydrogen. Okay. So here bond angle is, we know that is approximately equal to 109.5 because of the tetrahedral shape. Around the oxygen atom, there are two bonds, two lone pairs. So therefore, this is about approximately 105. We can say 104.5 also, but I'll take that one as 105. And nothing to say about this one because bond angle is 180, completely a linear type of a bond. Okay. So this is the molecule with the correct bond angles. Quickly finish this one. So isn't the third carbon sp? 1, 2, 3. No, that is not sp. Remember, here actually there are two carbon hydrogen bonds, another two hydrogen bonds, right? I didn't spread that one. Now you can see that one, okay? So without spreading that one, we can just write down here CH2. So try to understand there is a two hydrogen bonds. So here also there is another carbon hydrogen bond. That's why I put here carbon hydrogen here. Okay. Okay, Aarti, can you understand? I drew the diagram wrong. CH2, CH, and here CH2, O, C triple bond H. I told you to correct this one as CH2. I told you to correct this one as I told you to correct this one as CH2. There is a small typing mistake. Okay. Here I told you to correct this one as CH2. Please correct that one. And there is another question in the chat. Sir, can you explain how the second carbon is sp2? Second one is sp2. So here we have carbon hydrogen bond, right? So then how many whisper pairs are there? 1, 2, 3. So therefore hybridization is sp2. Okay, ne? So without writing that bond, without showing that bond, we can just write carbon hydrogen. So here also we have two carbon hydrogen bonds, but without writing it, we can just put here CH2. In organic chemistry, you will learn this is actually a short way to represent the bonds. We need to show, we don't have to show all the bonds. For example, now look at this one. Check whether you can understand this one. Now there is a molecule like this. If I ask you what is the hybridization of this carbon atom, what is it? sp3, right? Because that carbon is connected to three hydrogens, but we don't mention that one because in organic chemistry, our purpose is not to draw the Lewis structures, right? Lewis structures are just basic theories, understood, right? Therefore, without drawing these things, we can just write down here CH3, a short way, CH3, and here CH3, understood? In the university, you will learn that now when you have this kind of a group, actually we don't mention, right? When we have this kind of a thing, that means just imagine right? This is an organic molecule. This is a hydrocarbon. What is that hydrocarbon? So these edges are carbon, understood? Then here CH3, here we have hydrogen, here we have hydrogen, here we have two hydrogens, and here CH3. That means the molecule is 1, 2, 3, 4, 5. 5 carbon atoms are there. Hydrogen 3, 5, 7, 10. C5H10. But we can draw C5H10 in this way. Without writing any English letter, right? We can draw in this way. Can you understand? Right? This is C5H10. Easy, right? Right. You will learn those things in university level. Right. Okay. Now, this is the end of the question number 4. Let's move for the question number 5. We have to finish this one quickly. Yeah? Question number 5. Let's see. In the question number 5, first part is related to the hydrogen emission spectrum, and let's see what they have asked in this question. Draw a rough diagram of the spectrum as questions from number 1 to 4 below, that is associated with the emitted radiations of tube of hydrogen gas which has been excited by an electric discharge. Indicate the direction where frequency increases. Draw the name. The three main line series, those appears in the emission spectrum of hydrogen. Consider the electron transition associated with the excited electrons among the energy levels 1, 2, 3, 4, 5. That means they have asked us to draw the energy levels up to 5. Indicate the electron transition in an energy level diagram which is above energy levels. Inserting relevant energy level, indicate the electron transition associated with energy. Crazy. Easy. So they are just asking the hydrogen emission spectrum, that's all. And they're asking to mention the three main spectral lines. It's not difficult. Question number 5. Okay. Since they have asked to draw up to n equal 5, let me draw in this way. N equal 5. This is n equal 4. N equals 3. N equals 2. And this is n equals 1. Okay. Right. Now let's start. Lyman. All the electron transitions which are falling to the first principal energy level considered as Lyman. Lyman belongs to ultraviolet region. Then we have Balmer series. Balmer, which belongs to the visible light region. And then we have Paschen, which belongs to the IR region. And then we have Brackett. We cannot denote here Fun series, so therefore just ended up with the Brackett series. Okay. Indicate the direction where frequency increases. So which direction frequency increasing? I told you that for the Lyman series direction, the frequency and the energy increase. Energy, frequency increase. For the other way, lambda wavelength is increasing. Lambda increase for other direction. Finally, they are asking, inserting relevant energy level indicate the electron transition that is associated with the ionization of hydrogen. Remember, students, when you consider one hydrogen gaseous state atom, ionization means it's releasing one electron and forming H plus gaseous state cation. So this electron is going for which energy level as you think? N equal infinity level, right? That electron is released. So that is going for the N equal infinity level. So we can denote infinity level as dotted line N equal infinity, right? Ionization means the first electron, the very first electron in the energy level is going for the infinity level. So we can tell that in this way. This is the electron. It's going for the infinity level. Okay. So this is all about the hydrogen emission spectrum. So yeah, we have a doubt. So can we draw this from left to right also, right? First Lyman, Balmer. Yeah, for that direction also possible. You can draw this one from other way around also. That means Lyman series is there, and Brackett and the remaining series is here. Then frequency is increasing for which direction? For other direction, from right to left. Okay. Quickly, that is easy. Part A is easy. Finish this one. Follow a separate book for the paper class. Write down everything that we are going to learn in the paper class in that book. Okay. I'm sending all the papers to you all. You know that. So questions are available with you anytime. So follow a proper book. Sometimes you know that everything, some important things that is coming from my mouth, you have to listen to them and you have to note down if it is important for you, right? I'm not telling everything you to write down here, but if it is important for you, you decide and you write it quickly. Right? Are we done? 4:30. Done. Simple B. Consider the following species: lattices, silicon dioxide solid, H2O solid, magnesium oxide solid, carbon dioxide solid, iodine solid. Classify these species mentioning the type of lattice, particles inside the lattice, primary interactions, secondary interactions, and their conductivity. Give your answer by tabulating data in a table such that the species are included in columns while the properties A to E are included in rows. Okay, right. So that means they're asking us to prepare the table also. We have to tabulate the data appropriately. Let's see. They have given 5 molecules. Those are lattice structures. We know that lattice structures are, what are they? The molecules which are arranged in a particular order, and it is in the crystalline form. So in the table, the first column is lattices. Then we can take type of lattice. Type of lattice. And the next one, particles in the lattice. Particles. Then primary interactions. Primary interactions. Then secondary interactions. At last, we can include conductivity, whether it is conductive or non-conductive. Conductivity. Right. So the first structure they have given is silicon dioxide. Then H2O solid. Magnesium oxide. Carbon dioxide. And iodine solid. Okay, they have given very few easier structures. Number 1, silicon dioxide. What is the type of lattice? This is molecular lattice. Molecular lattice. So what are the particles inside the silicon dioxide? Silicon dioxide molecules. Primary interactions. We can tell that covalent. Covalent. What are the secondary interactions? A polar molecule. So therefore we can tell that dipole-dipole interactions. And London. Conductivity. Can they pass current electricity? No. Non-conductive. Non-conductive. H2O solid. H2O solid. What is the type of lattice? Same. Molecular lattice. Particles. H2O molecules. Primary interactions. Primary interactions are covalent. Secondary interactions, we can tell that hydrogen bonds. London. Can they pass current electricity? H2O solid. H2O solid. Can they pass current electricity? Quickly. No. Non-conductive. Solidic state. In the solid state, they can't conduct the electricity. Magnesium oxide. This is ionic lattice. This is ionic lattice. Particles, we have magnesium 2 plus and O2 minus. Cations and anions. Primary interactions, ionic bonds. Secondary interactions, no secondary interactions in magnesium oxide. Conductivity, magnesium oxide. Can they pass current electricity? Magnesium oxide. What do you think? Magnesium oxide. Conductive or non-conductive? Non-conductive. We have learned that in ionic compounds, solid state do not pass the current electricity. Carbon dioxide, molecular lattice again. What are the particles? A carbon dioxide molecules, covalent. Second interactions, this is a non-polar molecule, so they have only London forces, non-conductive. Iodine, this is actually atomic lattice, but remember this is homoatomic lattice. Homoatomic lattice means the same atom is there. Sorry, this is molecular lattice. Iodine is a molecule, so therefore homomolecular lattice. If not, we can just write down here molecular lattice. But let me put here homo molecular lattice. Why homo? Because the same element, iodine, homomolecular lattice. Particles, iodine molecules. Primary interactions, covalent. Secondary interactions, London forces, non-conductive. So this is the table that we have to fit. Okay, are we done? Right, okay. We have some questions. So magnesium oxide, secondary interactions. Magnesium oxide, secondary interactions. No secondary interactions. Sorry, here actually no interactions. Huh? Because magnesium oxide is a solid compound, ionic lattice. So there will be no secondary interactions. Huh? These are directly electrostatic attractions. Electrostatic attractions are not coming under the second interactions. Iron dipole can come for magnesium oxide. No. So where is the dipole in magnesium oxide? In magnesium oxide solid, we have only magnesium 2 plus cation and O2 minus anion. If you consider magnesium oxide aqueous solution, which is dissolved in water, right? We are going to consider magnesium oxide aqueous solution. Then that is ion dipole. Why? Water molecules are there. That is a dipole. Ions are there. Ion dipole interaction. Okay. Right. Now, students, simple C part, that is an addition thing. We haven't learned that one yet. Those are actually coming under electrochemistry, under the Faraday laws. But I'll discuss this one with you since you have learned this electrochemical cells and the electrolytic cells in your O-level type, right? Okay. Let's discuss that one. That's very easy, not difficult. Let's see. Simple C part, question number 5. An aqueous solution of copper 2 plus was electrolyzed, passing 0.5 ampere current, steady electric current for 30 minutes. What is the mass of copper that got deposit on the cathode, right? Remember, students, in electrolytic cells, actually, we have to learn a type of cells known as electrolytic cells. And the other type is electrochemical cell. In electrolytic cell, what will happen is we are using a battery and we are connecting these two batteries into two electrodes known as cathode and the anode, right? Cathode and the anode. So this is the positive charge one and this is the negative charge one. So the positive tip is connected to the electrode. That electrode is considered as anode. And the electrode which is connected to the negative tip is known as cathode, right? So they have here used copper sulfate kind of a solution, aqueous solution, right? In this way, right? Okay. Then what will happen actually? Remember, students, in the anode, always the oxidation reaction is possible. You will learn this, why these things are happening and everything under the electrochemistry. Okay, just now get the summary, that's all. Under the anode, what will happen is the copper metal. Just imagine we have used here two copper metals, right? Copper metal is going to oxidize into copper 2 plus aqueous by releasing 2 electrons. So in the cathode, what will happen is always in cathode reduction will happen. So in the reduction, what will happen? Copper 2 plus cations are taking 2 electrons to form copper metal. So they have asked here, what is the amount of copper metal that is deposited on the cathode? That means here you can see a layer where the copper metal is deposited in this way, right? So we need to find out the mass of that copper metal. So what is the current that they have passed here? 0.5. 0.5 ampere for 30 minutes. For 30 minutes, half an hour, 30 minutes. So students, they have given the molar mass of copper 63.5, and then they have given 1 capital F. What is this 1 capital F? This is equal to 96,500 coulombs. Actually, this is coulombs per mole, right? This is coulombs per mole. Students, this is very easy. We know that what is the charge of an electron? 1.602 10 to the power minus 19 coulomb, right? If you calculate the same charge for electron mole, that means charge of 1 electron mole, then what you have to do? You have to multiply this one by Avogadro number, 6.022 10 to the power 23 per mole, right? When you do this calculation, what is the answer you will get? You will get here 96,500 coulombs per mole. That means 1 Faraday is equal to the charge of electron mole. 1 mole of electron. Charge of 1 mole of electron is equal to 96,500 coulombs per mole. It is not exactly 96,500, 96,400, something like that. But approximately we are taking that one as 96,500 coulombs per mole, right? Now hereafter, you know what this mean by 1 Faraday. Yeah? What is 1 Faraday? Charge of 1 mole of electron. Charge of 1 mole of electron is considered as 1 Faraday, right? Now students, so this will be helpful for us when we are doing the calculation. So we need to find out the mass of copper deposited. How we can find out that part? Remember, there is an equation known as I equal Q over T. I means actually current, electricity, current. Current is passing through a circuit. And Q means that electric charge involved in the current. T means time. That means electric charge divided by the time gives the current. Charge is measured by coulomb. Time is measured by seconds. Then the unit is coulombs per second. That means unit of current is equal to coulombs per second. But we are using ampere also. That means 0.5 amperes means what is that one in coulombs per second? Same value, 0.5 coulombs per second. That is the current. Now, when this electrolytic cell is start to work, what will happen? They have used a 0.5 ampere current through 30 minutes, right? Then we can find out the electric charge going through this system. 0.5 amperes. Amperes means coulombs per second. Multiplied by 30 minutes. 30 minutes can be converted into seconds by multiplying 60 seconds. Then we know that the electric charge here, we can calculate this one as, if you multiply 60 by 0.5, again 30. 30 is 900 coulombs. That means when this cell is created, when this cell is starting to operate, 900 coulombs will go through the system. 900 coulombs. Then look at this one, 900 coulombs will pass through the system. Now we calculated that one. 900 coulomb using which equation? Q equal IT, right? Then we know that, just imagine, under the Faraday constant, I told you that 1 Faraday is equal to 96,500 coulombs per mole. What does mean by that? What does mean by that? That means charge of 1 mole of electron is 96,500 coulombs, right? Charge of 1 mole of electrons. Then here we can see there are 2 moles of electrons. According to the stoichiometry ratio, 1:2:1. That means here there are 2 electrons. Tell me students, if the charge of 1 mole of electrons is 96,500 coulomb, then what is the charge of 2 electrons multiplied by 2? Multiplied by 2. Can you understand? You are going to multiply this one by 2 moles. Then you will get the answer here. 2 into 96,500 coulomb. This is the charge of 2 electrons when the copper is deposited, right? When the copper is deposited, we know that copper 2 plus cation is taking 2 electrons to deposit copper. Then the charge involved in that reaction is 2 multiplied by 96,500. So what is the mass of copper metal? We know that when you consider, here actually we have 1 mole of copper. Molar mass is 63.5. Just imagine we have 1 mole of copper. We took that, here 1 mole, electron 2 moles, copper 1 mole. Molar mass of copper is 63.5. Then when you multiply moles by molar mass, the copper mass is 63.5 grams. Students, you can see that when this charge involved in that system, 63.5 grams of copper can be deposited. Can you understand? When this charge amount is going through the system, copper deposited amount is 63.5. But we calculated exactly how much of charge is going through the system, 900 coulomb. Then we can find out the correct mass, the exact mass of copper deposited is for 2 into 96,500 coulombs, we have this much. Then for 900 coulombs, how much we do have? Coulombs will cancel off, two zeros will cancel off, right? Then 965 is not divisible by 5, right? So therefore, yes, then we can do the calculation using the logarithms. 965 multiplied by 2. What is the answer? Answer is 10 here, 13, 1. Okay, 1930. And when you multiply 63.5 by 9, what is the answer? 45, 4 here, 27, 31, 3 here, 57. Okay, 571.5 divided by 1930 grams. This is the answer. Okay. Now do the simplification and get the answer. I will use the logarithms here. 5715. 5715. 5 is 4. 57 1 5. 75 70. And here we have 19 30, 19 3, 2856. Let me take this one as 1, then 4 1 7 4 0. Okay. Then I check the antilog of 4714. 4714 29 6 1. 29 6 1. Okay. But remember, we divided 571.5 by 1930. So therefore, this is actually equal to 0.2961. Approximately, we can tell that 0.3 grams is the answer. Okay. Don't worry. Exactly the same calculation we are going to do under the electrochemistry, right? So therefore, just get an idea. If you can't understand, it's completely all right. Doesn't matter. Right? Okay. Done. Okay, quickly tell me, are we done? Right, okay. So then students, uh, so what is the thing? Yes, so this is the end of the third paper book then, right? So we have completed that paper book also. So we are done with this one. Okay. So you will have the next paper book in the next week. Uh, Probably there will be MCQs, essays, both will be there. So that is the fourth one. Let's see. Okay. Right. So anything you want to ask related to this paper book? Anything? Any questions? Anything you want to clear? Do you have any doubts? Please raise your hand who understood everything that we discussed today up to now. Okay. If you have any doubts, put your doubts in the chat box. So won't be discussing A-level paper hereafter, here later on. No, Jeroshan. Jeroshan, my plan is to discuss only model papers. I have so many model papers. I want to discuss in model questions, not the past papers. For the past papers, I will conduct a separate session for you all. Right? So not yet. Still, we have time. Still, 24 batches should go for the examination, right? So therefore, for them only we have to do the past papers. So now you just do these model questions and study well, do the homework, study the theory parts. After the fourth unit, after the completion of the fourth unit and the fifth unit, then you can go for the past paper questions as well. Because when you analyze the past paper, at least now you can't do half of the paper. At least you can't do the half of the paper. Do you know that one? Still you can't try the essay paper properly. You can only, yeah, you can even try one essay completed question even in the past paper book. You try, will you? So therefore we have to discuss many more things. First of all, let's do some model questions from the theories we learn. Later I will discuss past papers with you. Okay, for separately a past paper class will be there for you all. Okay, later, not in this class. I'm using only this class to increase your marks in your term test examinations, right? And that will affect your A-level examination by following this. Right, okay. Still we have time. First of all, let's have a break. After the break, I'm going to start to discuss the FWC paper. There are some good MCQs to discuss. After the break, let's discuss that paper. Okay, take a 10 minutes break. 5:10. I'm going to start the class at 5:10, and after the break, let's start FWC paper. Okay, students, let's start. So this is actually 2024 FWC first term examination. Right? Let's see. First question, MCQ number 1. Name of the scientist who involved in the following statement. Electron pairs surrounding the central atoms of a given molecule of iron are arranged in a way to keep maximum spatial distance apart from each other. So actually, really, I was wondered after seeing this question. The reason is this statement they have given in your resource book, right? I'll tell you with the page number. So in page number, the page number 52, under the valence shell electron pair repulsion theory, right? So this is the general chemistry resource book, right? So in that book, they have given a statement. So in that statement, they have given two scientists. So they have directly asked that question in this paper. So students, this is the thing you have to understand. Resource book is actually now, I told you, that is the best studying material you have for the chemistry as well as for the biology. So therefore, sometimes you have to depend on the resource book also, right? I never thought they will give this kind of a question, but see the question in theories also. I didn't teach this one because I thought that this is not that much important. The name of two scientists, because we are learning the name of scientist in the first unit. Right? We discussed many names, but here actually I didn't thought that they will ask this kind of question. But anyway, remember they're asking these kind of questions also, right? So I'm planning to discuss this one with the 26 page also, because they also want to know this one. They have given this kind of question in the paper like this, right? So for answer for this one is question number 1. Answer is first one. The scientist names are Ronald Gillespie and Ronald Sidney. Okay. So what did they actually say? They said that electron pairs surrounding the central atom of a given molecule or iron are arranged in a way to keep the maximum spatial distance apart from each other. That means they are telling that if there are lone pairs around the central atom, they will repel. Okay, so that's what they said. So therefore, question number 1 answer is first. Sorry. Question number 2. X belong group P group elements placed in the given oxygen ion. Actually, they have given it's belong to group S block elements placed in the given oxygen ion, which is the suitable group for X. Right. X is given like this, and it is connected to oxygen atom in this way. And there is oxygen atom in this way, right? So the overall charge, sorry, there are no charges here. Overall charge of the oxygen ion here is minus. Okay. So can you tell me this element, that means capital X, belong to which group? Tell me your answers in the chat box. Quickly tell me your answers. Let's see how you can get the result for this one. Yes, Akash, correct. What about the others? Quickly tell me the answers. No, Sehanti, wrong. Wrong. That is wrong. Gimali, wrong. Try it again. Quickly, others. Tell me your answers. Mariam, correct. Yeah, that's the answer. Lashmi, correct. That's the answer. Gimani, I'm not asking the element. That element belongs to which group? Capital X. Sorry. Sachin, correct. Yeah, remember, students, remember this one. Now you can see that capital X is connected to uh, oxygen atom, 4 oxygen atoms. Two of them are connected to the double bonds. So therefore, no charges on those 2 oxygen atoms. Then definitely for the other 2 oxygen atoms, they have connected to single bonds. Definitely there should be negative charges, minus, and here also minus. But can you say that? Can you see that here overall charge here they have taken, that is -1. But when you consider this anion, this is actually 2 minus, because there are -2 charges. That means someone should be positive. Who is that positive? Then who is the positive one? The central atom, capital X. This one should be positive. If it is positive, now check the valence electrons inside the X atom. 1, 2, 3, 4, 5, 6. And remember, this positive sign is representing that capital X has removed 1 electron. That means in the valence shell of capital X, how many electrons were there? 7 electrons. If it is 7 electrons, this is belong to which group? Group number 17. 17. Try to understand. This belongs to group number 17. Okay. Understood? Not group number 16, that is 17. Question number 2, answer is first one. Question number 3. Which one is false statement about cathode rays? When cathode rays collide with the matter particle, it may release energy. Yes, we have learned that X-rays are producing that way. Ne? Cathode rays are colliding with the metal surfaces and the X-rays are produced. Discovery of cathode rays help to discover the atoms. Yeah, in order to study the atoms, the discovery of electron was very helpful. Correct. The cathode rays show particle nature, do not show wave nature. Wrong. Cathode rays have both particle nature and wave nature. That is wrong. When cathode rays travel in a cathode tube, its momentum increase. We can say like this: the momentum is increasing when the high voltage source is increases. We know that in the cathode ray tube actually works with the high voltage source. So when you increase the voltage difference, definitely the momentum and the energy, all of them are increasing. So therefore this is actually partially correct. But let's see. Let's go for the other one. Positive rays travel in the opposite direction of the traveling of cathode rays. Yeah, that's obvious. We know that one. So then the most appropriate answer, the false one, is actually what we can take. Number 3, third one. Cathode, when cathode rays show particle nature, do not show wave nature. That is wrong. So simultaneously, particle nature, wave nature, both is there. Right? Both can show. Both can be shown. So therefore, third one is the answer. Question number 3, answer is third one. Discovery of cathode rays help to discovery of atoms. Right? That's correct. Discovery of atoms means in order to analyze the atom, in order to gather the information of atoms, the discovery of electron was cathode rays was helpful. So therefore, question number 3, answer is third one. Question number 4. What is the maximum number of electrons belong to the quantum number n equal 3 and ml equal 0? Right? In the question number 4, they have asked to calculate the number of electrons involved with n equal 3 and ml equal 0. Right? We know that in the third principal energy level, n equal 3 means third principal energy level. In the third principal energy level, there are 3 sub-energy levels, 3s, 3p, 3d. And there is only one orbital in this sub-energy level. There are 3 p orbitals in the p sub-energy level, and there are 5 orbitals in the d sub-energy level. Right? So, we know that the orbitals, right? That means we can give the magnetic quantum number for this one as 0, and this is minus 1, 0, plus 1. This is minus 2, minus 1, 0, plus 1, plus 2. Right? So they're asking n equal 3 and ml equal 0. This is ml equal 0. No? So how many electrons are there? 1, 2, 3, 4, 5, 6. So we can take the answer for this one as question number 4. Answer is second. Easy. Sorry. Question number 5. In the following statement, which is which is false about the subparticle atom, subparticle of atom. Beta particle is particles of moving electron. Yes, that's correct. Neutron is not necessary to present in all atom. Yeah, that's correct, because of the hydrogen atom. Because hydrogen is the only element which is not containing neutron. Because of the hydrogen atom, the second statement is correct. Mass of an electron is 1837 times less than mass of a proton and neutron. Yeah, approximately the value is correct. A speed of electron is decreased when the electron travel from low energy level of atom to high energy level of atom by absorbing energy. Yeah, that's correct. Remember, students, when the electron is passing from low energy level to high energy level, that electron is actually absorbing the energy. So therefore, it has to stop in the high energy level. So therefore, actually, what will happen? As they mentioned, the speed of electron is decreased. Number 5, H plus ion contain proton in its nuclei and contain electron in its first energy level. Sorry. Contain contain electron in its first energy level. Okay, the idea is H plus ion contain proton in its nucleus, and there is electron in the first energy level. Is that correct? After removal of the one and only electron of hydrogen, where will be the electrons? No electrons, right? No electrons in the hydrogen plus. So therefore, the false statement is 5. Question number 5, answer is 5. Question number 6. Correct increasing order of the bond angle of the following compounds. They have given H2O. Capital A is H2O. Capital B is carbon dioxide. Capital C is hydrogen sulfide. Capital D is OF2. So these are the compounds. If I draw the Lewis structures, H2O, it's like this. Carbon dioxide, it's like this. Hydrogen sulfide is also like this. And OF2 also like this. We know that among these 4 molecules, carbon dioxide has the highest bond angle because 180. And H2O, H2S, OF2. We know that H2O is about 104.5 bond angle. Now, when you compare OF2, look at this one. OF2. First of all, H2O and H2S. Let's go for H2S. Remember, students, oxygen is the electronegative atom, therefore pulling electrons. So here also sulfur is the electronegative atom, pulling electrons from hydrogen. But remember, sulfur is not much as electronegative as oxygen. So therefore, the pulling electron is low. That means the electron density around the sulfur atom is low. So we know that around oxygen atom, electron density is greater. Then when the electron density is greater, what will happen? The repulsion forces will create. In this way, repulsion forces will create, right? Electron repulsion forces will create. So when the electron repulsion forces will create, what will happen to the bond angle of H2? What do you think about it? When the electron repulsion forces created, this bond angle is reducing. But hydrogen sulfide is not like that. Then we can compare that between A and C, which one has the highest bond angle? Definitely the highest bond angle belongs to C than A. Then if you consider OF2 molecule, OF2 molecule, what will happen? Yeah, we know that here fluorine is the one who taking all the electrons from oxygen. Fluorine is the element who are taking all the electrons from oxygen. So therefore, around the oxygen atom, electron density is very low. Therefore, no repulsion forces. Then the bond angle is greater than we expected. So therefore, we can tell that here we have what? Fluorine is pulling electrons, so therefore its bond angle is a bit lower. Okay. So the lowest bond angle belongs to OF. Yeah. So because that is because we know that around the oxygen atom electron density is low. So therefore, no repulsion forces. So therefore, bond angle is low. But when you consider water molecule, we know that in oxygen atom, the oxygen atom will pull the electrons. So therefore, the electron density around the oxygen atom is greater. So the repulsion forces will created. So therefore, bond angle is greater than we expected. Definitely, A should have a greater bond angle than D. Then when you compare A and C, which one has the highest bond angle? Around the oxygen atom, we know that again, it has the electron density, therefore repulsion forces are greater. Then A should come here. So this is not the characterization. C should come here and D should come here. Do we have this kind of a variation? DCAB. Yes, DCAB is given in fourth one, right? Look at this one, students. Again, look at this one. We know that carbon dioxide has the highest bond angle because 180. And the next one is H2O. Why H2O? Right? So H2O molecule, oxygen atom is taking electrons from the hydrogen atom. Therefore, the electron density is greater. Between these two bonds, electron repulsion forces will create. Right? Therefore, this bond is becoming more wider. Then A has the next highest one. Then when you consider here sulfur, sulfur is less electronegative than oxygen. So therefore, sulfur is not pulling electrons as much as oxygen. So therefore, it has a less bond angle than H2O. But here OF2, when you consider, oxygen is the one, not one who taking electrons. So fluorine is the one who pulling electrons. So therefore, bond angle is very low, no repulsion forces. So this answer can be seen in the fourth one. Question number 6, answer is 4. Yeah, H2S is less than H2O, right? Previously I wrote wrong. H2S is less than H2O. Sorry. So if electronegativity is high, bond angle decrease. Isn't that? Bond angle is increasing. If the electronegativity is high, oxygen is pulling electrons, central atom is pulling electrons. If the electronegativity of the central atom is greater, bond angle is also greater. Question number 7. Question number 7 is a simple calculation. What is the energy of electromagnetic particles which has the wavelength lambda is equal to 11,000 angstrom? We know that angstrom is equal to 10 to the power minus 10 meters. Then the answer will be 1.1, 1, 2, 3, 4, 10 to the power minus 7 meters. Okay. Yes. Then we can calculate here the energy. How do you calculate the energy? We can apply here E equal hc over lambda. We can apply the equation E equal hc over lambda. When you apply that equation E equal hc over lambda, look at this one. H is Planck's constant 6.626 10 to the power minus 34 joule seconds. Velocity 3 meters per second divided by lambda 1.1 10 to the power minus 7 meters. Meters will cancel off, per second will cancel off. Students, let's assume that 6.626 is equal to 6.6. Then here 1 and here 6. Then 6 multiplied 3 is 18. And here 10 to the power minus 34. Minus 7 will go for the numerator as 10 to the power plus 7, 15. Then 18 into 10 to the power minus 19 joules. Right? Then 1.8 10 to the power minus 18 joules. Answer is, what is the answer? Second one. Question number 7, answer is second. Okay. Do the calculation perfectly. They have taken an approximation 6.6. Here, this one should be 10 to the power minus 6, no? Yes. Sorry. This one should be 10 to the power minus 6, no? Minus 6. And here minus 6. Then 10 to the power plus 14. Minus 20. Minus 9. Then question number 7, answer is not the second one. That is third one. Right. Shall we go for the question number 8 quickly? Question number 8. In question number 8, they're asking, in the following molecule, which one has the highest atoms in the same plane? Right. Let's draw the molecules PCl5. When you draw the PCl5 molecule, we know that here 3 chlorine atoms and phosphorus, they are in the same plane. But we know that 2 chlorine atoms are not in the same plane. So that means 1, 2, 3, 4. 4 atoms are in the same plane. Sulfur trioxide. In sulfur trioxide, I do not mention lone pairs. Okay, 1, 2, 3, 4. 4 atoms are there. Sulfur hexafluoride. We can consider that sulfur hexafluoride means in this way. Can you understand? So here, how many atoms are in the same plane? 1, 2, 3, 4, 5. 5 atoms are in the same plane, right? Then sulfur tetrafluoride, SF4. SF4 is CSO type, right? So if it is CSO type, one is outside the plane, one is inside the plane, and there is a lone. So there is only 3 atoms in the same. Then when you consider BRF3, BRF3, T-shape, right? Yeah. So this is actually, there are 4 atoms. Then you can see that which one has the highest number of atoms in the same plane? SF6, right? So therefore, question number 8, answer is number 3. Question number 8, answer is number 3. Question number 9, answer. A particle moves with kinetic energy E and wavelength lambda. What is the kinetic energy of this particle when this particle moves with 4 lambda? Right, okay. We know that. Look at this one. Question number 9. According to the de Broglie's equation, we know that lambda equal H over mv, right? Okay. And we know that kinetic energy is equal to half mv squared. When you multiply this one by m, both side, we know that this is half mv total squared. Okay. So they have given the kinetic energy and the wavelength. They haven't given anything related to the mass either. Okay, we can simply take that energy of a particle. So therefore, this can be kinetic energy. If it is a wave, we know that we can apply this kinetic energy Ek is equal to Hc over lambda. Yeah, right. That kinetic energy can be what equal to the energy of that particle, right? Then we can tell that if the kinetic energy of this particle, when the particle moves with 4 lambda, that means let me take this one as Ek dash Hc over lambda dash. This is equation number 1 and this is equation number 2. Right? Then 2 divided by 1. Ek dash is equal to Ek. This is Hc over 4 lambda divided by Hc over lambda. Cancel off. Then we have the answer. Ek dash is equal to Ek over 4. That means the kinetic energy, new kinetic energy is equal to Ek over 4. So Ek over 4 is given in the second one. Question number 9 answer is second one. Right? Okay, my calculations are Hc over 4 lambda. Then Ek dash divided by Ek. Yes, in this way. Right? Question number 9. Answer second one. Right, okay. Next one. Question number 10. Can you guess the answer for question number 10? That is actually a qualitative question. X, Y are two elements of two successive periods. That means in two different periods. Two successive period means next to the other one. In 1 atm and pressure 1 atm pressure and 25 degrees Celsius. Temperature, these two elements are different physical states. These two are in two different physical states. Unpaired number of electrons in Y is greater than X. These two elements form oxyanion AO4 minus in its higher oxidation state, which is possible for X and Y. What is the answer? What is your guess? Yes, answer is chlorine and manganese. Remember, students, we learned that in the third unit, we learned that manganese is forming permanganate anion, MnO4 minus, right? And chlorine is forming perchlorate anion, ClO4 minus. Check whether it is satisfying the conditions. Manganese is it is in the highest oxidation state +7. Chlorine is also in its highest oxidation state +7, right? And then they have given they are in two different physical states. Yes, manganese is a solid and chlorine is a gas. We know that. And the next one, the number of unpaired electrons. Number of unpaired electrons in Y is greater than X. Okay. Now here, who is X? Who is Y? Yeah, Y is manganese. Why? We know that chlorine 3s2, 3p5. So in the p sub energy level, there are 1, 2, 3, 4, 5, only just one electron. In manganese, we know that 3d5, 4s2. 1, 2, 3, 4, 5. 5 unpaired electrons are there. So therefore, X is chlorine, Y is manganese. Answer is number 1. Question number 10, answer is number 1. So that's a good question. Let's move for the question number 11. In acidic medium, ethanol CH3C double bond OH is oxidized to carboxylic acid by potassium permanganate. What is the transferred number of electrons when 10 moles of ethanol oxidized to CH3C double bond OH? Okay, right. So this is interesting. Let's see how we can do this calculation. Question number 11. First of all, guess your answers, all of you. Put your answers in the chat box. Those who did the calculation, put your answers. Okay, Rafa. Let's see. Others? Right, okay. Lashmi. Good. Quickly, others? Put your answers. Okay, Marin, right. Okay, let's see. Question number 11. In acidic medium, we know that permanganate, this is reacting with CH3C double bond OH, converted to carboxylic acid, CH3C double bond OH. Right? We know that permanganate is going to reduce into Mn2 plus. So this is redox. Okay. Students, we know that here manganese oxidation state is +7 and here +2. They have clearly mentioned that when we use 10 moles of this compound, we are using 10 moles of this compound, right? There are 10 moles of this compound. Then how many moles are here? We know that 2 carbons, here also 2 carbons, here also 10. Understood? Right? Then, can you see that here, C double bond OH, there is a carbon atom here. There is another carbon atom here. In this molecule also, 2 carbon atoms are there, carbonyl group carbon and the other. When you calculate the oxidation state of this carbon atom, that means a carbon atom in the CH3 group, and in this molecule, carbon atom in the CH3 group, they are equal in oxidation state. Their oxidation state is not changing. Then who is the one changing oxidation state here? The middle carbon atom, right? The carbon atom is in the carbonyl group. Remember, this is known as carbonyl group, right? In organic chemistry, we are going to learn this one. This is considered as the carbonyl group. So this is carbon atom in the carbonyl group. So when you calculate the oxidation state for this one, it will be carbon-carbon, no difference. Here +1, -1, and here +1, -1, +1, -1, +1. So here carbon's oxidation number is +1. But remember, student, there are 10 carbons. Therefore, +10. Here, what is the oxidation state? Carbon-carbon, no difference. Here there are 3 oxygen atoms. Then -1 +1, -1 +1, -1 +1, +3. But remember, there are 10 carbon atoms. Therefore, +30. Right? Therefore, +30. What is the difference? 10 to 30, the difference is 20 electrons. That means these 10 molecules has released 20 electrons in order to convert into this. So here the difference is +7, +2. That means the difference is 5. So in order to equalize, we have to multiply this one by 4. Right? When we balance in this one, we have to put here 4 in this way. We know that balancing a redox reaction means we have to equalize the total increment with the total decrement. Can you understand? So here you can see that the total increment is 20 electrons. 20 electrons are removed. And here 20 electrons are gained. Right? So here, try to understand these 2 carbon atoms are not changing their oxidation states, but the carbon atom in the carbonyl group, they are changing their oxidation states. That's why we have +10 and here +30. Therefore, difference is 20 electrons. In this question, they're asking, in acidic medium, This molecule oxidizes into another molecule by permanganate, which what is the transfer number of electrons when 10 moles of ethanol is oxidized to acetic acid? Answer is 20 electrons. Question number 11, answer is third one. Right, good. I saw that many of you gave that answer. Very good. Very good. Question number 12. What is the electron pair geometry and the shape of the molecule of the ion ClFO plus? So this is the structure, Lewis structure. So answer should be yeah, that's why I was looking, right? There is no bipyramidal, right? They have given trigonal pyramid, tetrahedral, square planar, tetrahedral, trigonal pyramid. We don't have answer here. Right, okay. So question number 12, that is all. We don't have answer for this one here. Trigonal bipyramidal is not given. So therefore no answer. Right. Next one, question number 14. What is the correct about the oxyacids HClO, HClO2, HClO3, and HClO4? When oxidizing number increases, oxidizing power also increases. What do you think about that one? Is that correct? When oxidizing number increases, oxidizing power. When the oxidizing number increases, not the oxidizing power. Reducing power is increasing. Okay? Right. Then the next one. Electronegativity of chlorine atom increases as follows. Yeah, that's correct. When the oxidation number increases, we have learned that electronegativity is increasing, right? So I think answer for this question is second one, but let's see. Number 3, all the oxyacids have pi bonds. Now, if you consider HOCl, is there any pi bonds? No pi bonds. Both of them are sigma bonds. So therefore, that's wrong. Chloric acid is accepted nomenclature. Chloric acid is the accepted nomenclature for HClO4. Wrong. Nomenclature for HClO4 is, the correct name is chloric 7 acid. We know that when we are writing a name, we cannot start from the capital letters. That is wrong. So therefore, the fourth statement is wrong. When oxidizing number increases, acidity property of the oxide acid, it decreases, not decreasing, that is increasing. Remember students, when the oxidation number increases of the chlorine atom, it will pull the electrons. So therefore hydrogen can easily release from the compound, right? If the chlorine atom has highest oxidation state, what will happen? Chlorine is pulling electrons from everywhere. Then hydrogen is easily removable. So therefore the fifth statement is also wrong. Question number 13, what is the answer? What is the answer? Question number 13, answer is second one. Question number 13, answer is second. Right. Let's finish 14 and 15. Question number 14. What is the number of gaseous sodium plus ions which is formed by sodium atoms using 4.94 kilojoules energy? Sodium's first ionization energy is 494 kilojoules per mole, right? Look at this one. What is the number of gaseous sodium plus ions? Number of gaseous sodium plus ions formed by sodium atoms using 4.94 kilojoules energy. Right. Okay. So that's very easy. Look at this only. So they have given that the energy, total energy. What is the total energy? Total energy is 4.94 kilojoules. Right. 4.94 kilojoules. So in order to find out the sodium moles, number of sodium moles, we can divide this total energy from the first ionization energy is given. What is that one? 494 kilojoules per mole. So therefore answer is 0.01 moles. These are the sodium moles, right? Then how do you find out the sodium atoms? In order to find out the sodium atoms, you can multiply this one by Avogadro number. 6.022 10 to the power 23 per moles. Then you will get the answer. This is 10 to the power minus 2. This is 10 to the power 23. Then the answer is 6.022 10 to the power 21 particles. Question number 14. What is the answer? Number 1. Right? Okay. Did you get the answer? They're asking yeah, got it, right? Question number 14. What is the false statement about the size of atoms and ions? Atoms have no particular size according to quantum kinetic theory. What do you think about it? Atoms have no particular size according to the quantum kinetic theory. No, it's not like that. There is a definitely size of an atom. So we can't say that there is no particular size for the any quantum theory or classical mechanical theory. Anyway, always atom has some kind of a size, radius. That's wrong. Let's go for the second one also. Size of the cation is less than the size of its atom. Correct. Size of anion is greater than size of its atom. Correct. In second period, from left to right, the size of the ions and atoms increases. Wrong. We know that from left to right, what will happen the radius? It is decreasing. Helium has lowest atomic size. Yes, that is also correct. So I think here actually we have two answers. Atom have no particular size according to the quantum kinetic theory. We cannot exactly tell like that, students. In the quantum kinetic theory, atoms has no particular size. Yeah, let's take the answers for question number 15, number 1 and number 4. But I will check that question number 15, answer number 1 again, and let you know about that, right? My idea is actually, whatever the theory, we can take some kind of a size. Now, even though now in the quantum theories, we represent that atom is look like a electron cloud model. That means electron is surrounded, uh, that means atomic nucleus is surrounded by the electron cloud. That means there are no energy levels or anything, just electron cloud. Even though there is electron cloud, we can measure the size of the atom. That means particular size, we can approximately tell that one, right? So that's why I told you that there is a size. But anyway, for now, just keep two answers for this one, number 1 and number 4, right? Right. We have 10 more questions for this one. I will put the answers for these 10 questions in the WhatsApp group. Students, what about the Isipatana College paper? Shall I include this paper in the paper book, our paper book? Isipatana College paper? Shall I include that one in our paper book? Okay, right. Okay, students. Then this is the end of the third paper book, and we discussed few questions in the WCA paper also. So we are going to meet in the next week paper class with new paper book. Sometimes I might include only MCQ papers. Sometimes I might include essay papers as well. Both will be there sometimes, if not MCQ completely, right? So we have discussed so far 200 plus MCQs, 4 structured essay papers and 4 essay papers. So that is actually a very good thing. So in future paper classes, we are going to increase the time also, and let's increase the number of questions also, right? Because I want to discuss a lot of questions with you before you go for the examination, right? So this is the only way that you can prepare for the examination properly, right? So by keeping that mind, do the questions again and again, and if you have any doubts, send me a message through WhatsApp and let's discuss that. Okay, right? Okay, then let's meet on the next Monday class. Until then, bye bye, have fun. Good evening, folks.